Alright, here we go. We got 7.2 mass to mole and mole to mass conversions. I'm going to show you how to do both of these, and then at the end of the video I'm going to do 2 extra ones. So if you think you're getting these right away, you don't have to go that far, but if you're not, alright, make sure that you go further and write them down. Alright, also a good idea, once you think you've got these, to pause, do them on your own, push play, and then see if you're getting them right. Here we go. Alright, first of all, you should have your flow chart out. Alright, your stoichiometry flow chart, make sure you have that out. Everybody should have it in the packet. Once again, for my CP class, you will not have this liter, so you will not have this part. You'll just have molar mass and Avogadro's number here for grams and particles. For honors, you do have that. Alright, and make sure you have a periodic table. Here we go. Alright. We are given, we're going to do a mass to mole problem. We are given...
Any teachers still in the building that would like to join the culinary club, please come join us in the Family Consumer Science. We have a little bit of food left. Today was Italian. Teachers left in the building, if you'd like to join the culinary club downstairs, we have a little bit of food left. Thank you.
Here we go back. If you have 23.2 grams of bromine react with excess lead, how many moles of lead bromide would be produced? Alright, important part here. Like every time we want to do, we know we're going to have a phlegm chart here. We know we're going to write our given 23.2 grams. Alright, it's important that you're writing down your chemicals here. Now, and this one I just gave you the words for the chemicals. So, what does this mean? 23.2 grams of bromine. Which one of these is bromine? Well, on your periodic table, yes, Br is bromine, but I see it here and here. Which one is it? Well, reacts with excess lead. This right here is lead. Alright, how many moles of lead bromide would be? Well, this right here is your lead bromide. Okay? So when I say bromine, I must mean this chemical here. So make sure you write down your chemical Br2. So 23.2 grams of Br2. Alright, it says reacts with excess. Whenever you see this word excess here, alright, just means you have a whole bunch of it. It means we do not have to worry about this lead right here. Alright, how many moles of lead bromide would be produced? So let's go back to our chart over here. Alright. We were given grams, and we're going to call this grams of A, which means we're given just A, just a chemical, so grams of a chemical. And we want to go to moles of a different chemical. Alright, grams of one chemical to moles of a totally different chemical. So in our chart here, we see that we're going to have to use the molar mass, and we can go from grams of A to moles, and look at our chemicals the exact same, A and A. And then we can go from moles of A to moles of B. So, how do we do this? Well, I don't want grams of bromine, so I know grams of Br2 is going to go down here. Well, where can I go from grams? I can go from grams to moles, and it's got to be the same chemical. You might want to write this down. Anytime you have grams and moles together, your chemical has to be the exact same. Grams and moles, Br2, Br2, they have to be the same. Alright, we'll continue on. I do want moles, that is correct, but I don't want moles of bromine. I want moles of lead bromide, this one. So I'm going to have to cancel out moles of bromine and go to moles of lead bromide, this one right here. Alright, now let's go about and do our numbers. Since we are finally to where we wanted to be, it says how many moles of lead bromide, boom, there it is. Okay, moles and grams, what's my number for mole? Hopefully remember my number is 1. Where do I find grams? I go to the periodic table, so let's go back to our periodic table. Let's find bromine. Alright, bromine's right here. It's 79.9. Alright, and I've got 2 bromines, so I need to multiply this by 2. So I'm going to do that in my calculator right now. 79.9 times 2 gives me 159.8. And that's going to go right here. Remember, when you think grams, think periodic table. Alright, now we have a mole over a mole. Notice here, when you put mole over mole, this is where your chemicals can change. Alright? So when we had gram and mole together, chemicals have to be the same. When you put a mole and mole together, this is where our chemicals change. When you have mole and mole together, let's go back to our chart. Look what we do. We're going to use our mole ratio here. Alright? So when mole and mole is together, what's the mole ratio? Remember, it's these numbers in front, our coefficients. So Br2 is here, and what's its number? Oh, the coefficient is 2, straight from here. Moles of PbBr4. Mole and mole together, what's my number here for this? There is no number, so it means it's 1. Alright? Grams of Br2 goes away. Moles of Br2 goes away. I'm going to be left with moles of lead bromide, exactly what I want. So let's multiply on top, divide on bottom. So 23. Okay, so we have our moles of Br2 down here, moles of PbR4 here. Let's get our answer. Sorry, the camera messed up, so sorry if there's a jump in this. Let's try this again. So 23.2 divided by 159.8, and then divided by 2. Your final answer here is going to be 0.0726. And I ran out of room. I'll just write below moles of PbBr4. Yes, it is important you write your unit and your chemical. Okay? Let's try another one. Alright, this time I've got moles of aluminum. So I come through here. Yes, aluminum is Al. If it's by itself, it's the element. Remember, if it's together with something, that means it's a compound. Alright, so I got 4.32. Oh, and the last one I should have done my steps. I got 4.32 moles of aluminum. Alright, reacts with excess chlorine. That means I have a whole bunch of this, can throw it out. How many grams of aluminum chloride? So, sorry about the last one, I totally forgot my steps. Please write down what you have below your chemicals, and now we'll do our lovely phlegm chart. So 4.32 moles of aluminum, that's what I'm given. So I've got moles, and I want to go from moles to grams. If I go back to my steps, I got moles of one chemical, and I want to go to grams of a totally different chemical. So I first need to go from moles to moles of a different chemical, and then go from moles to grams. So here we go. I don't want moles of aluminum. Alright? So moles of aluminum is going to go down here. Sorry, it looks like we're having issues today with recording and camera. We'll start back. So on this one, I'm given 4.32 moles of aluminum. I want to cancel out my moles of aluminum. What can I go to? Well, from moles of aluminum, I want to change my chemical. I don't want aluminum anymore. Remember, I want to go to aluminum chloride. So if I go back on my flow charts, I can go from moles of one element to moles of a different element. So I'm going to put moles. What am I trying to go to? Aluminum chloride, and that's this one right here. So AlCl3. Now ultimately I want to get to grams. So I know then moles is going to come down here. And I can go from moles to grams if you look at your flow charts. Alright? Don't try this in one step, because remember, I'm going to a different chemical. So your first step is to go from moles of aluminum to moles of aluminum chloride, and then from moles to grams. All right, your numbers here. Mole and mole together. This is the only place where you can have different chemicals, okay? Aluminum, aluminum chloride, we have mole, mole. This is where we get our ratios, so our coefficients. All right, my coefficient for aluminum right here is 2. Aluminum chloride, my coefficient's right here. That's also 2. All right, moles and gram together. What's my mole number going to be? Hopefully you remember, for moles and grams when they're together, a mole is 1. Grams is from the periodic table. So we find aluminum is 27.0. All right, and the chlorine here is 35.5. So aluminum was 27.0. Chlorine is 35.5. I have 3 chlorines, so I need to multiply that by 3. Alright, and that's going to give me 106.5. Alright, and then I'm going to add my aluminum and my chlorine together. Alright, and when you do that, you get 133.5. Multiply on top, divide on bottom, you'll see that your moles of aluminum cancels, your moles of aluminum chloride cancels, and you're left with grams of it, which is what we want. So 4.32 times 2 divided by 2 times 133.5, and this answer turns out to be 577 grams of AlCl3. Alright, there's my grams of AlCl3. So 577. Alright, that's mass to mole, mole to mass. If you want to try out a few more, I'm going to give you a couple more. So let's move on. Alright, this one, I don't tell you what type it is, but we can figure it out. I give you 7.32 grams, alright, of hydrogen gas. That's for this one right here, so 7.32 grams. And reacts with how many moles of oxygen? This is oxygen right here, right? Because H2O is called water. So, I don't know how many moles of this. I'm going to put that there. Now we know what we start with and what we want to get to. So, I got 7.32 grams of H2. Alright, I've got grams of one chemical to moles of a different chemical. So look at your flow charts. Alright, I do not want grams of H2, so that goes down here. And if it's grams, there's only one thing we can go to, and that's moles. And it's got to be of the same chemical. Okay, gram and mole together, both of those have to be the same chemical. Alright, I want to cancel out moles of H2 because I don't want H2, I want O2. And remember, when you put mole and mole together, this is where our chemical can change. We go in now and get our numbers. Mole and gram together, my mole is 1. Grams from the periodic table. Hydrogen on the periodic table is 1.0. And there's 2 hydrogens, so this is 2.0. Mole and mole together. Where do you find the numbers? Hopefully you said coefficients. My coefficients. So H2, my coefficient here is 2. O2, my coefficient is 1. So once again, mole and mole, coefficients. Alright, grams of H2 cancels out. Moles of H2 cancels out. I'm left with moles of oxygen. That's what I want. So multiply on top, 7.32 times 1 divided by 2 times 1 divided by 2 again. Alright, so I'm just doing these. Remember, multiply on top, divide on bottom. And I get 1.83 moles of O2. And I have my answer. We're going to do one more. Once again, if you're at this point and you haven't paused it yet to try it on your own, pause it real quick, try it on your own. Then unpause it, see me do it. Alright, I'm given 2.33 moles of aluminum. I look through this whole thing. Remember, if it's just the element, just look for it. There it is, aluminum. So I've got 2.33 moles of this. Reacts with excess copper sulfate. Okay? How many grams of aluminum sulfate will be produced? This sometimes is where your back of your periodic table can be helpful. This is aluminum and this is sulfate together. If you don't know what sulfate is, you can find it back here. So this is what we're talking about. I want to know how many grams of this. So I'm going from moles of aluminum to grams of aluminum sulfates. If you use your flow chart, that'll be good. Alright, moles of aluminum. So I know moles of aluminum will go down here. Alright, what do I want to get to? Well, I don't want it to be aluminum anymore. I want it to be aluminum sulfate. So the first thing you can do is input moles of aluminum sulfate up here. Remember, when you put mole and mole, this is the only time your chemical can be different. Okay, so you got those together, the only time your chemical can be different. But I don't want moles of, I can write that out, aluminum, that's really ugly, sulfate. I want grams of aluminum sulfate. Alright? Here we go. Mole and mole together. Our numbers come from our coefficients. Alright? Here's aluminum. There's my coefficient 2. Here's aluminum sulfate. My coefficient's 1. Alright? Moles and grams together. The mole is 1. Grams we find in the periodic table. Alright, we got to find aluminum, sulfur, and oxygen. So let's go back here. Aluminum's right here at 27.0. Sulfur's 32.1. Alright, oxygen 16. So aluminum, we said, was 27.0. Sulfur was 32.1. Oxygen is 16. Now, be careful on how many you have. Alright? Al2. So, the 2 goes with the Al. Just 2 of them. So, we're going to multiply that one times 2. Alright, sulfur's inside of parentheses. The subscript here, if there's none, is 1. We got a 3 outside the parentheses, so we're going to multiply these. So, 3 times 1 is 3. So, multiply by 3. Oxygen's got a 4 inside the parentheses, 3 outside. Multiply these together. That means we have 12 of these oxygens. So here we go. 27 times 2 is our 54.0. 32.1 times 3 is going to give me 96.3. And 16 times 12 is going to give me 192.0. I'm now going to add all these up. 54 plus 96.3 plus 192. And when I added these up, I got 342.3. So mass from the periodic table, 342.3, goes right here. Multiply on top and divide on bottom. You will see moles of aluminum cancels. Moles of aluminum sulfate cancels. We're left with grams, which is what the question asks for. So 2.33 times 1 divided by 2 times 342.3 divided by 1. And you get an awesome answer. Now I ran out of room here, so I'm going to write it right down here. Okay, so this equals 399 grams of Al2SO4 parentheses 3 aluminum sulfate. And that's how you do these. Alright? So write down questions if you have them in class, and